Hello, my dear friend, myself Poonam Sachdev. Now I am again here with you. Let's welcome to you first. And now, Chapter 1 Real Numbers. We are beginning of your class 10. The number, real numbers word is not new for you, right? As you already well aware with the number system. Okay, so let's recall in a short all those things. First of all, my dear student, you know very well n. What is n? N is a set of natural numbers and it begins with 1, 2, 3, 4, 5, and so on. Here, this is infinite set. Set of natural number is an infinite set. Then let me introduce W. W is a set of whole numbers. All of you know very well this thing. Whole number, it begins with 0, 1, 2, 3, 4, and so on. Again, I should say that is also an set of infinite. Okay, it is also infinite set. And one more thing you can observe here, student, all the members of natural numbers are contained by whole numbers except 0. Here see, here why 0 is the extra member. Rest of all the members of natural number are here. Okay. And in W, here only extra member is 0. Right. Now, let me introduce one more set, that is set of integer. We call it I. And you know very well that is also infinite set. All the negative integers, 0 and positive integers, they are the members of set of integers. Here, so dear student, here one more set is with us. You know very well that is set of rational number, that is Q. Actually, it is defined by Q. Reason behind that, it is the fractional number, and when the numerator is divided by denominator, we must have quotient. Okay, so in such a case, this set is known as quotient. Q, the symbol is coming from there, but likely to say this set is set of rational number. Now, which numbers are there? So we can't list out as N, W, and I. Just we can put it in a symbolized form, P by Q, where P and Q. These two are the members of set of integers I, and one more condition, Q not equal to 0. What is Q here? Q is the denominator. So the member of Q, sorry, the denominator should not be 0. That is the major condition. That is all the fractional number that we are concluded in the, they are included in the set of rational numbers. Now, immediately after that, you have studied irrational numbers in your class 9. You are well aware with that, right? So, let me introduce here in the 10th class, R is a set of real numbers. Here, R is a set of real numbers. It contains all the rational numbers as well as irrational numbers. So combinedly, I should say the all the rational and irrational numbers are contained by set of real numbers, and it is defined by capital R. So this set we are going to study here, right? Now, dear student, along with that, if when we further proceed inside that, this is the introduction about the set of rational real numbers. Okay, but dear student, here if I ask you, little bit things should be clear in your mind regarding this number. You all are well aware with the prime numbers, right? The word is not new for you. You know very well which numbers are prime numbers. The numbers which is having a number which has two, we can define this, a number which has only two factors. A number which has only two factors. All those numbers are called, these factors are called prime numbers. Okay, they are known as prime numbers. Now let me give you one example. Suppose I am talking about 5. Is it a prime? Let's check. The factors of 5 are, which are the factors? 1 and 5. You can see they have only two factors. Which two factors I am talking about? As we know that 1 is a factor of each and every number and number itself. 1 and number itself. 1 and number itself. It indicates that that is the prime number, right? It indicates that that is a prime number. Some more example I am giving you verbally. Suppose we have 13. 13 is having only two factors, 1 and 13 itself. Clear to you? So, dear student, this is the definition of prime numbers. So immediately after prime number, along with that, one more definition we have to look out for, that composite numbers. Okay. So how to define this composite number? All of you know very well. A number which has more than two factors. A number which has more than two factors. All those numbers are called all those numbers are called composite numbers. You know very well this definition. Now let me give you one example. Okay. Suppose I have, and I'm taking one example. Suppose 15 is with me. Okay, the number is 15. Now what are the factors of 15? Of course, you will say 1, 1 15 ja 15, 3 5 ja 15, 5 3 ja 15, and 15 1 ja 15. So, my dear student, here you can see 1, 3, 5, 15. Such a way, this 15 is having four factors. It has four factors. So, dear student, whenever a number is having more than two factors, then that is called composite number. So, according to that, 15 is a composite number. Some more examples we can have. Suppose we are choosing 42. 42 is having factors 1, 2, 3, and then 6, 7 also, right? And then 6, 7, then you can work out on 21 and then 14. These are the factors of 42. So it is more than two factors it has, so that is also composite number. These are the examples. Okay. Now let's move further inside the chapter. So before we proceed inside the chapter further, let's have some notes related to this prime and composite number, which are quite useful. So please, dear student, keep these in a mind that 1 is neither prime and nor composite. Please keep this in mind. 1 is a number that is neither prime nor composite. Right? This is very important fact which we are going to use inside the chapter. Now, one more fact is with us. 2 is the smallest prime number. 2 is the smallest prime number. Right? This thing also in a mind. 2 is the smallest prime number. And along with that, one more fact about 2 with us is that 2 is only even prime number. 2 is only even prime number. Okay, that is even also and prime number also. No such a number except 2 is even, and that is also prime. Rest of the odd, all the numbers of the prime, they are odd except this 2. Clear to you? So this is very important fact. Now, let's proceed towards the Euclid's theorem. Okay, Euclid's division algorithm for finding SCF. So let's work out upon that new topic. Now, let's begin the chapter. It's an important topic, that is Euclid's division algorithm for SCF. Okay, dear students. Now, what we are going to do in that, before we proceed in that, first let me introduce through this word Euclid, from where this word comes. Do you know, student? Euclid is a Greek mathematician. He was a Greek mathematician, and he devised an interesting method to find the SCF of two numbers. Okay, Euclid himself, he devised an interesting method to find the SCF of two numbers, and that method is known as Euclid's division algorithm for SCF. Clear to you? Euclid himself, he devised this method. That's why from his name, the method name is Euclid's division algorithm for SCF. Okay. Now, an algorithm is a stepwise process to solve the problem. Algorithm word is also, you are well aware with that word. You know very well what is algorithm. So please note down. An algorithm is a What is algorithm? An algorithm is a stepwise process. You know very well. It is a stepwise process. Step by step we are doing to solve a problem. To solve a problem. Yeah, this is stepwise process to solve the problem. Now, dear student, what we are going to do in that? Few things that I am discussing here with you. Now, dear student, the steps taken to find the SCF of two numbers are this way. You can see on your screen. First step is identify the greater number of the two. Second, consider the greater number as divided and the smaller one as divisor. Third step, find the quotient and the remainder. Next step, if the remainder is 0, then the divisor is the required SCF. Otherwise, we need to go to the other step. Next step, take the remainder as the new division and the divisor as the new dividend. So, repeat these steps 3, 4 and 5 till the remainder 0 is obtained. The last divisor for which the remainder is 0, that is the required SCF. So, my dear student, these are the steps to find the SCF of the two numbers. When we applied it in exercise, in the question, we will easily solve all the questions one by one. So, in the chapter 1 real numbers, one more important topic that we need to go with, that fundamental theorem of arithmetic, right? Now, let's try to understand what is that. What is the fundamental theorem? It is on your screen. Every composite number can be expressed as a product of primes, and this decomposition is unique apart from the order in which the prime factors occur. So, my dear friends, it follows that a composite number can be uniquely expressed as the product of prime factors. It means that any composite number we can express as the product of prime factors. This is known as fundamental theorem of arithmetic. I hope it's clear to you. So, in the introductory class of the chapter 1 real number, let's know about the highest common factor. You know, dear student, highest common factor, that is known as the SCF, right? Highest common factor is SCF. It is also called the greatest common divisor. The meaning of greatest common divisor is similar to SCF, that sometimes you will find in a short form GCD. It is known as GCD, greatest common divisor. Yes, you. And one more thing that you are well aware with this word, lowest common multiple, or sometimes least common multiple also. In place of lowest, you will find least common multiple, that is also known as LCM. So my dear student, these things we are going to study here, okay? That is SCF and LCM with the prime factorization method, okay? Now, some important clues I am giving to you here. Now, my dear students, I am introducing properties of SCF and LCM of given numbers. Let's see which are they. First property, the SCF of given numbers is not greater than any of the numbers. Second, the LCM of given numbers is not less than any of the given numbers. Third property, the SCF of given numbers is always a factor of their LCM. Fourth is, the SCF of two co-prime numbers is 1. Next, the LCM of two or more co-prime numbers is equal to their product. One more which is quite important, which we are going to apply again and again in the question. If small a and small b are two numbers, then a multiplied by b equal to SCF of AB multiplied by LCM of AB. This is very important result to find unknown things. Whenever out of these four things, these two numbers, their SCF and their LCM, out of these four things, any one of the missing, then we can put other three's value easily in this. We can find. Now, dear student, one or two important things which is in front of your screen, on your screen. Every rational number can be expressed as a decimal. The decimal representation of a rational number is either terminating or non-terminating repeating. These terms already you are well aware. In class 9 we have studied terminating and non-terminating. And one more important thing is that if the denominator of a rational number written in standard form contains no prime factors other than 2 and 5, then it can be represented as a terminating decimal. Otherwise, it can be represented as a non-terminating repeating decimal. So, my dear student, here all the way the important things which we are going to apply in the exercise, in the sums, we have seen here. So, this is introductory class. Go through it again and again. Then this video will be useful for you.